Okay, so I'm gonna go over the cases for the partial fraction decomposition. It's not that difficult. It's very simple actually. Let's go for the linear factor case. So let's try to do that. So the first thing I need to do is factor, right? So this is gonna be the factor the denominator. Another thing I need to check if this is written in improper fraction or proper fraction, right? So in this case right now, this is written in improper fraction, so I don't need to worry about anything, right? Because we talk about this degree, the degree of the denominator has to be greater than the degree of the, I'm sorry, the degree of the denominator has to be greater than the degree of the numerator, right? So that's the case in this situation, so I don't need to worry about that, right? So I need to factor now. So this is going to be x minus 1. So if you factor that out, you get this, right? A, b, x minus 1. So that's, I need to find what's a and b, right? So multiplying both sides by x squared minus x squared minus x, which is the same thing as this, right? So this cancels. That's going to be ax minus 1 plus bx, right? So now you need to set x equal to 1, right? Or let x equals to 1. This part right here, erase that. So if you let x equals to 1, you need to plug it here, right? So this is going to disappear, the a. So you're going to get b equals, if you plug 1 here, you're going to get negative 1, right? So b equals negative 1. And now you need to solve for a, right? So a, we don't need this anymore. If we solve for a, we got b here. I'm sorry about that. So b equals negative 1. Now for a, we let, let's see what we can do. Oh, this is ax minus 1 bx. So we let x equals to 0. This disappears. This is going to be negative a. 4. A is going to be negative 4. So a is going to be negative 4. Okay? So that's how you do that. And then you plug it in. Okay? So that's the answer. That's the answer for part 1, or the problem 1. Okay. Next question. So this is a linear case, right? The next question is we need to factor again. So this is going to be x plus 5, x plus 4. Again, this is in proper form because the degree of the denominator is higher than the degree of the numerator. So we need to solve this. So we have 3x plus 10, x squared plus 9x plus 20. And then we have a, x plus 5, b, x plus 4. Multiply both sides by this expression, right? And we get this. This cancels this with that, right? 3x plus 10, a, x plus 4, plus b, x plus 5. So we need to let x equals to negative 4. Let me fix that here. Let x equals to negative 4. So this disappears. So we get b equals negative 4. That's going to be negative 2. So that's how you find b, right? And for a, so if we let x equals to negative 5, this will disappear, right? And we get negative a, negative 5, that's going to be negative 15, and 10 is negative 5. So a equals 5. So we got that. So the answer should be what? The answer should be a. So a should be here. So a is 5, and b is negative 2. So that should be the answer for the problem, right? So we don't need anything of that. We don't need this, right? So this is answer. Yes, so that's the answer. You can rewrite it if you want. You can say this is negative x plus 4 plus 5, x plus 5, as they have in the answer here, right? If you want, but it is the same thing. Okay, so this is the linear factor case. This is the easy case, right? The next case is when you have repeated linear factors. So number 5, you have to factor, right? So that's going to be a and b, right? But you need to see what it is. This is x plus 3, x plus 3, right? So you can see that this is the same as x plus 3 to the second power. Therefore, this is going to be ax plus 3. And then the next one is going to be x plus 3 to the second power, right? So if you do that, you multiply both sides by this thing, x plus 3 to the second power, x plus 3 to the second power. This cancels out. You get negative 7x plus minus 15 equals ax plus 3, b, just b, right? Because that cancels out. Let x equals negative 3. This disappears. You get b, negative 3. That's going to be positive 21, positive 21. And subtract from 15, you get 6. So that's the answer for b. You keep that here somewhere. So b6. Now if we solve for a, let's do that in another color. Okay, so again, I don't know why I erased the other one. Right, so this is ax plus 3 plus b equals negative 7x minus 15. Now we can use another number, right? So let's say we use, well, we already have b, so I can just plug it in, right? So this is going to be ax plus 3a, and b is 6, and this is going to be negative 7x minus 15. Can combine like terms, subtract negative 6 in both sides. This is going to be negative 7x minus 21 equals ax plus 3a, right? So you can factor here negative 7. This is going to be x plus 3. And if you factor here a, you're going to get x plus 3. So you can see clearly that a equals negative 7. So now you need to write it in that form. So this is going to be negative 7, x plus 3, and b is going to be 6 over x plus 3 to the second power. And that's the answer for that problem, right? This part. Okay. That's repeated linear factor. Let me see if there's another one here. Actually, I put three more. So if it's confusing, we're gonna do this a lot. Okay, next is this one, right? The 20, the thing, right? So this is 20x plus 9, 25x squared plus 20x plus 4. Okay. And you need to find what's a and b, right? And first of all, you need to see what kind of expression do you have. So you need to factor. So 25x squared plus 20x plus 4, x squared. I have to use the easy method here. So this is going to be 100. So this is going to be x plus 10, x plus 10. But remember, when you do the easy method, you need to divide by 25 again, right? 25, 25. And here you're going to get 2 over 5. And this is going to be 2 over 5. And if you multiply both sides by 5x plus 2, this is the factor form, right? Since you have 2 copies, you just need to write it once with the second power. So this is going to be a repeated linear factor, right? So we need to write here 5x plus 2 once. And then because this is to the second power, we need to write 5x plus 2 twice, right? So that's the expression. So I need to multiply both sides by this guy, right? Is 5x plus 2. So both sides by 5x plus 2 to the second power. And here you have to do the same, 5x plus 2 to the second power. So this cancels. You get 20x plus 9 equals a 5x plus 2. And then b is just going to be by itself. Again, almost the same story, right? So now I need to find whatever number I can put, right? So I'm going to put 0. When x equals 0, or let x equals to 0, that's going to disappear. So I'm going to get 2a plus b equals 0. That's going to be 9, right? So I have a system of equation here. I keep that. So I'm gonna use another number. Let's see, I use 1. Now let x equals to 1. So if I let this equal to 1, that's gonna be 7a plus b, right, equals 1, that's gonna be 29, okay? So I have this system of equations. So I'm gonna bring these together right here. So I'm gonna multiply the first equation by -1, so I'm gonna get -29 equals -7a minus b equals 9, 2a plus b. The b disappear, so that's gonna be -5a equals -20. Divide by -5, you get 4, right? Okay. And now for b, I mean, you can use either equation, whatever you want, right? So this is I'm gonna use the second one. 9 equals 2 times 4 plus b. That's gonna be 1, right? B equals 1. So I have the problem almost set up, right? So the answer for this problem is a equals 4, 5x plus 2 plus b is 1, 5x plus 2 to the second power. And that's the answer, right? As you can see here. Okay, not difficult. Okay, next, this one. Same thing, right? I need to factor the denominator. Is this in proper form? Yes, because the degree of the denominator is greater than the degree of the numerator, so I'm fine. So I need to do what? I need to factor the denominator, right? So that's not gonna factor by grouping, right? Because you're gonna get -7 over -5 over 11. That's not gonna work. So you have to do the rational root theorem, no choice, right? So P over Q, so plus or minus 1, plus or minus 5 for this guy, right? And for this guy, the leading term or the leading coefficient is 1. So that's gonna be plus or minus 1, right? Okay, so if we do that, well, any number divided by 1 is the same, right? So I don't need to worry about this 1. So that's gonna be just plus or minus 1, plus or minus 5. You always try to do 1 because that's easy. So 1 minus 7, right? You need to plug 1 in each x, right? So you get 1 minus 7 plus 11 minus 5. So you get -6. This is 6. So they cancel. So that's one of the solutions, right? X equals 1 is one of the solutions. But in reality, it's x minus 1 the factor. So you have to use synthetic division, right? So synthetic division of this denominator, 1, -7, 11, -5. So you drop 1, this is 1, -6, -6, 5, 5, and this is 0, right? So it's x minus 1. Remember, when you're dividing by degree 1, this expression, you're gonna get degree 2, right? So this is gonna be x squared minus 6x plus 5, right? And then you can see if you can factor this further. So this is x minus 1, x minus 5. That works out, okay? So this is the factor form. And notice also that here this is x minus 1 to the second power. So this is gonna be a repeating linear factor, right? So in reality, this is my answer, right? After I do all this calculation. So yeah, so now let's continue with the partial fraction decomposition, right? So now we have a over x minus 5, and then we have b over x minus 1 plus c over x minus 1 to the second power, and this is going to be what? This in the numerator, right? Over all these things, right? X cubed minus 7x squared plus 11x minus 5, and you need just to move, right, these things here. So this is going to be multiplying by this thing, right? So this is x minus 1 to the second, x minus 5, both sides, right? Okay, so if you do that, this disappears. You get -2x squared plus 19x minus 13 equals a x minus 1 to the second plus b is x minus 1, x minus 5 this time, and c is going to be just x minus 5. So now you need to set up the problem, right? So let's see, let me put that in green. So let x equals to 5, right? If you let x equals to 5, this disappears, right? And then you get 4, that's 16a. And then 5 you put here, that's going to be 25, that's negative 50. 5, that's going to be 45, if I'm not wrong. Let me see, 5, 45. Carry for actually 95, right? 95, and this is minus 13. This is going to be 45, 45, 35, and 3, that's going to be 32. 16a, a equals 2. So that's the value of a, right? So that's a. Now I need to solve for b, right? I'm not going to erase everything. I'm just going to erase some of this stuff. Okay, so what else I can do? Let's see. I put them both. So if I put 1, right? If I put 1, this disappears, and you get negative 4c. If you put 1 here, you get negative 2. And if you put 1 here, you get 17, and 5 is 4. So c equals to negative 1. Okay, so that's c. I found it. Now I need to find the last one. I need to find b, right? And I'm done. So let's see. Let me put that in red. So if I need to find b, okay. So let's use another number that we didn't use before. Let's use 0. So that's going to be a for 0. Then if you use 0, you get a positive 5b, right? And then you get 0, you get negative 5c. And this is going to be, we use 0, 0, and that's going to be negative 13. So we know that a is 2, and b is, we're looking for that, c is negative 1, so that's going to be positive 5. This is negative 13. So this is 7, subtracting both sides. Let me double check. Okay, so we said that is 0, that's negative plus positive 5. We said that is 0, right? So this is going to be negative 5c. 0 is 1, 0, 0, 0. Okay, so we have a equals 2, 5b. C we say it's negative 1, so that's 5. Let's see what's wrong here. Let me double check again. So we said that x equals to 0, right? So if x equals 0, that's going to be a for this one, because negative 1 squared is 1. 1 times a is a. If this is 0 and this is 0, that's going to be 5b. And if this is 0, this is going to be negative 5c. And if this is 0, this disappears, so this is negative 13. Right? So a, we said that it was 2. 5 minus 5 times negative 1. Right? So this is negative 13. Let's see what happened here. So this is 7, right? Plus 5b equals negative 13. This is negative 20. Now it's okay. 5b, so b equals negative 4, right? Actually, it's 4, right? 5. Actually, no, it's negative 4. Negative 4. Okay, so now we get the problem, right? So we have a, b, and c. We need to plug it in, and that's it. We're done. So I'm gonna move this here, and we just need to plug it in the thing, right? So a equals 2 over x minus 5. B equals negative 4 over x minus 1. And c is negative 1 over whatever this is, x minus 1 squared. That's it. That's the answer. Okay. Next problem. Okay. So this is a little bit more intense, right? So hopefully we can do this. Okay. Let's see. Okay. So this is the quadratic factor, right? So we have a repeated quadratic factor, or we might not have the repeated quadratic factor, but we might have something a little bit tedious. So we have, they already factor that for us. So this is going to be a over x plus p, because this one is to the second power, you need to write as a linear form, right? Or linear factor. So this is going to be x squared plus 1. And then the other one is dx plus e. It should be equal to x squared minus 5. Because this is quadratic, this one must be linear. If this is quadratic, this must be linear. If this is linear, a constant should be here. Okay? So make sure that you remember that. Okay, now let's solve this thing, right? Not big deal now. So we need to set this equal to the fraction, right? Which is the 2x squared minus ax squared minus 10 plus 3x cubed. Let me move this a little bit. And then we have, what is the other thing? Minus 9x. So 2x squared minus ax minus 10 plus 3x cubed minus 9x divided by x squared plus 1, x squared minus 5, and this is equal to that. If you multiply both sides by whatever we just found, right? The factor forms, right? Which is this thing, x squared plus 1, x squared plus 5 on the left side, and on the right side we do the same. Right? This cancels out with this, so you get 2x squared minus ax squared minus 10 plus 3x cubed minus 9x, and here we have all this stuff, right? So this is going to be ax squared plus 1, x squared plus 5 plus b x plus c multiplied by these things, so you get x squared plus 5, and then we have dx plus e. Let me make this smaller because it's not gonna fit. Dx plus c multiplying by this x squared minus 5 here, right? So this is ax squared, this is minus 5. And then this is bx plus cx squared minus 5. And then dx plus e, x squared minus 5 cancels out with that. So this is x squared plus 1, okay? Now you need to compute this thing, right? So the first thing I need to see if I can do it a little bit or find something faster. So let x equals to 0. Let's see if that happens. So x equals 0, disappears this, disappears that. So 0 means that this is gonna be -5, right? Yeah, 0, -5a. And if you put 0 here, disappear, 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 disappear. So this is -10, a equals 2. That's good news. So I found already one of the solutions, right? That's good, even though it's tedious, right? So I found one. So a equals 2, I already know that. So ding, 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 ding. Okay. However, I'm not gonna be able to do the rest the same way for this problem, right? Because if I put here, I cannot do anything after that. That's not gonna work, right? So I need to do another way to solve the problem. So the other way to solve the problem is, since you already have a, you can expand this, right? So if you, for example, if you expand this part right here, let me change the color too, by the way. If you expand these parts, this part here, you will get x to the 4. Let me put that in different color. You get x to the 4 minus 5x squared plus 1x squared. So that's going to be -4x squared minus 5 times 8, right? So that's going to be a multiplying all that stuff. And then you have b. You have to do the same thing, right? But I'm going to do these first, these two first. So that's going to be bx plus c times x cubed minus 5x. That's going to be that part. And the other part is going to be, okay, so we have the bx plus e, and we need to multiply that by x cubed plus 1, right? And then we need to do FOIL one more time, right? So as you can see, it's not that easy to do this. But it's tedious. It's not that it's hard, it's just tedious. Okay, now we need to expand this one more time. So this is ax to the 4 minus 4ax squared minus 5a. So we need to do FOIL here, right? And if you do FOIL here, you get bx to the 4 minus 5 bx squared plus cx cubed minus 5 cx, and then this is going to be whatever that is, right? Okay, so then we have to expand this one more time. So this is going to be dx to the 4 plus dx plus EX cubed plus E. Okay, so I have everything, right? Now I need to set up the power of X4 here with all the X4. So I have 1, 2, 3, and that's it. So you have 2, which is the coefficient of X to the 4, and you put all the coefficients of X to the 4 from all this long expression, right? Which is A plus B plus D. But you already know what's A. You found it before. So this is A2 plus B plus D. So this disappears. So 0 equals B plus D. Okay, that's good news for me. Okay, so this disappears. I don't need that anymore. So I have this. And now I need to do for the, what is that? What is it called? For the third degree, right? So for the third degree, I have this, I'm sorry. For the third degree, I have this one. Third degree. So I'm gonna look for third degree here, right? So third degree, I have 1. Third degree, I have 2, right? So I have C. I have C plus E equals 3, right? So I have 2 equations right now. Okay. So now we start with the second degree. So we have second degree here. So let's start with the second degree. This one, second degree, second degree, and that's it. So we have -8 on the left side equals in the right side -4A, and then we have -5B. But you already know what's A from before. So this is -A equals A is 2. So that's going to be -8 equals -5B, right? So that means this A disappears. So this is 0 equals -5B, B equals 0. Oh, that's great. So now I found B. Okay. And because B is 0, now that allows me to solve more things. Because I know that B is 0, I can find D now. D equals 0. I found D already. Good. Let me put that here. And let me put a highlighter here so I know that that's that. Okay. So I have A, B, and I have A, B, and D. I need to find C. Okay. So now we start with degree 1. What is degree 1? Let's see what is degree 1. Degree 1, we have this guy right here, right? So degree 1, I have, let me put that in different color because then after it gets confusing. Let me put that in red. Have this one, -9, right? So degree 1, I have 1. Degree 1, I have 2. So -9 equals -5C plus D, right? And let's see if I have D equals 0. So this disappears, right? Because I have D disappears. And I have -9 equals -5C. Okay. Okay, well, let me see if I did this right. -9 equals -5C, and plus D, it should be equal to -9. Okay, so C should be 9/5, but I'm sure that that's not right. Let's see what happened here. Let's check. You have to always check when you're doing these things, okay? Be careful with this. So far we have B equals 0, which I think is right. D equals 0 is also right. A equals 2 is right. The only one that you need to check out is the D and E, okay? However, I have one constant here. Let's see. Let me find out for the constants first. So I have, for the constants, let me leave that at the end. For the constants, I have -10. Let me clear this up. For the constants, I have just one, right? And this one, 2 constants. So let's see what happens. -10 equals negative 5a plus e. So you know that a equals to 0. I mean, 2. So that's going to be this, right? So this is going to cancel out because this is going to be negative 10 and negative 10. So that's going to be 0. So e equals 0. So if e equals 0, then c equals to 3. Then that's what you need to do. Okay? Yeah, that's right. Okay, so we have e, we have c. Do I miss something? Okay, something is wrong here. Okay, let's check. Something is wrong here. Let me do that calculation again, okay? This part. Let me do that again, just in case I'm missing something out. So I have 2x squared minus ax squared minus 10 plus 3x cubed minus 9x. That's that part, right? So I need to multiply a times x squared plus 1 as a factor form, and x squared minus 5. That's the a. The bx plus c, I need to multiply that by x, right? By x and x squared minus 5. And the dx plus e, I need to multiply that by the, what is it, x squared plus 1. Be careful when you're doing this, okay? So now, like I said before, let x equals to 0. So if this is 0, I get negative 5a. If this is 0, this disappears, and this disappears. So that's right. So this is negative 5a. And if this is 0, this disappears, this disappears, this disappears, this disappears. So a equals to 2. Okay? So that's right. So a equals to 2 is right. Now let's continue. Okay. Let's see what happened here. So now I'm going to try to expand the right side, right? So this is going to be a x to the 4 minus 4x squared. And then this is going to be negative 5. Okay. This is the left side again. So I'm going to put that here. And then I have plus, and I have bx squared plus cx times x squared minus 5. And then I have dx squared plus ex times x squared plus 1. Okay. If you're watching this and you want to skip that part, this part a little bit, you can do that. The previous part that I made mistake, you can skip that, right? So now you need to set this equal to the left side of the partial fraction, right? So this is going to be 2x to the 4 minus ax squared minus 10 plus 3x cubed minus 9x. So you need to multiply both sides by that. That cancels out, right? And blah, 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 blah. So we need to expand this, right? So this is going to be ax to the 4 minus 4ax squared minus 5a plus bx to the 4. Let me move this a little bit. Okay. So we have bx to the 4 minus 5bx squared. Okay. And then we have cx cubed minus 5cx. And then I need to do this side, right? So that's going to be, that side is going to be dx to the 4 plus dx squared plus ex cubed plus ex cubed plus ex, right? So now you set it like we did before, right? So you have this 2x squared to all x squares like I did before. Okay, so I think this is just a numerical mistake. So this is 2 equals a plus b plus d. Again, you know that a is 2. So this is going to be plus b plus d. Cancel, cancel. 0 equals b plus d. Okay, so that's right, like I did before. Okay, so we have this one. Now let's do x cubed. X cubed is this one right here. So x cubed, let's look on this side, which one is x cubed? This is x cubed, this is also x cubed. So let's do that. Okay, so 3 equals c plus e, right? And there's nothing I can do here so far. So I'm just gonna keep this. Then we have the next one. Then we have x squared. Let's do that, x squared. X squared with x squared, right? X squared, x squared, x squared. Okay, so we have -8 equals -4, -5, actually -4a, -5b, and d, right? And then we know that, for example, here we know that a equals to 2. So -a, -4 times 2 minus 5b plus d. So this is -a, so this cancels with that. So -5b plus d, it should be equal to 0, right? So that's the other part. Okay. Okay. So we have that. Now we need to set up the constant, right? Set up the constant in red. Constant is -9x. Okay. Sorry, not a constant. With the to the first power, the exponent to the first power, right? So 85 with this and this, right? So we have -9 equals -5c plus e. Okay. Yeah, that's what it is, right? And then, so far I just found a, right? Okay. Let me erase that from the previous part that I was doing. Probably, I'm sure that that's right. But anyway, and then the last part is this part right here. We put that in blue. I have the -10 here, -5, and that's it, right? So I can solve for a. So -10, well, we knew from before what was a, so I don't need to worry about that. So I have these things here, right? So I have 0 equals b plus d, and then I have 0 equals -5b plus d. So I need to multiply the first equation by -1. So let's see what happens. So 0, -b minus d, 0 is -5b plus d. So this disappears, right? So you get -b. So this is 0 equals -5b. Actually, it's -6b, right? Because we're combining the first equation. So that's going to be -6b. Anyway, b is 0. So b is 0. If b is 0, and we know that a was what? A was 2, right? So now we can solve for everything else, right? So a is 2, b is 0, then therefore d is also 0. And now we can find the rest, right? So let's see what else we can do. Okay, so I don't need this equation because I already solved for b and d. Okay. Okay, let's see what else I don't need this one because I already solved for b and d. Okay, so I have c and e and c and e, so I can solve for that. C plus e, -9, -5, c plus e. So I can multiply by -1 this equation and I get 3 equals -3, -c, -e, and this is going to be -9, -5c plus e, right? So this cancels. You get -6c equals -12. So c equals to 2. Okay, that's good. So if c equals to 2, I can solve the rest. If c equals to 2, I can solve this one. So that means that e equals to, if I use this equation, I know that e equals to 1, right? -2 on both sides. So e equals to 1. Okay, so I found my solution. So this is 2 over x, right? 2 over x. I'm doing this part, by the way, if you're confused. 2 over x plus b is 0, c is 2 over x squared plus 1, d is 0, and e is 1. So that's the answer. Okay, that's the answer for that problem. A little long because I made a mistake, but if you keep track, it's not a big deal. Okay, be a little careful with this. And the last case, oh, this is repeated quadratic factor. We didn't do repeated quadratic factor here. No, this is not repeated. Okay, so this is gonna be another tedious one, right? Okay, let me do that. Okay. Okay. So let me do that for you. Okay. So the first thing I need to do is what? I need to factor, right? I need to factor. Okay, so they already factored that for me. So I just need to say A, x plus 1, and then B, x squared plus 3 to the first power. But because this is quadratic factor, I need to put bx plus c here. And then the other one is going to be dx plus e is going to be written as x squared plus 3 to the second power. Remember? That's how you do it. Now, if you multiply both sides by this expression, x plus 1 times x squared plus 3 to the second, right? And then you do the same thing here, x plus 1, x squared plus 3 to the second. This cancels with this. So you get negative 4x to the 4 minus 26x squared minus 2x cubed minus ax minus 44. That's the left side of the partial fraction, right? And then you have to, on the right side, you have a x squared plus 3 squared, right? And then plus bx plus c. And that actually, you're gonna have here, yeah, you're gonna have here x squared plus 3, x plus 1, and this is gonna be cancel out with that. So this is dx plus e times x plus 1, right? So the first thing I should do is if something disappears. So I'm gonna do this. To find at least the first term, let x equals to negative 1. If I let that happen, let me change it in yellow. So if I let that happen, this is gonna disappear, right? This is gonna disappear, and I get negative 1, so that's gonna be 4, 16a, and this is negative 1, so this is gonna be negative 4, negative 1 is negative 26, negative 1 is positive 2, negative 1 is 8, and this is negative 44, negative 30, negative 28, negative 20, negative 64. So negative 64 equals 16a divided by 4, by 16, you get negative 4. So I already found a. Okay, that's good. Okay, so I don't need this anymore. So now let's see if I can do another one like that. Let's see if something can simplify this problem a little bit to make the computation easy, right? So I can let x equals to 0. Let's see what happens if I do that, because that's an easy number. So this is gonna be 9a, 0, that's gonna be c, 0, that's gonna be 3c. That's not too bad. So this is 0, yeah, that's 3c. And I said that that's gonna be 0, so that's gonna be 1, right? So 0, c, 0, 3c, 0 is 3c anyway, right? So, and then here I have 0, this disappears, 0, this disappears, so this is e. 0, this disappears, this disappears, this disappears, this disappears, that's nice. Negative 44, so negative 44, I have a, so that's gonna be negative 36, plus 3c plus e, so that's gonna be add 36 in both sides. That's gonna be negative 8, right? So that's gonna be 3c plus e. Okay, I have one equation. I don't know if that's gonna be useful, but at least help me somehow, because only 2 variables here. Okay, so let's see, let's continue with this thing. Okay, let's see what else I can use. If I let this equal to 1, let's see what happens. Okay, let's see if something cancels out. That doesn't take me too long to do this, right? So this is 16a. If this is 1, this is going to be b 1. I think this is not helping too much. Okay, so I'm going to keep that equation here, and I'm going to try to set up the other ones to solve the problem. So I need to expand this thing basically, right? So, okay, so I'm gonna do, okay, let me put like a little block here. So this is gonna be a x to the 4 plus 6x squared plus 9, right? And you have all these things right here. So bx plus c times x to the 3, x squared, okay, x cubed, x squared plus 3x plus 3. That's this part, right? Okay. And then you need to do the other part, right? So this is going to be dx squared plus dx plus ex plus e, right? That's that part. And I need to do the middle part. And you know that this is going to be ax to the 4. But you know that a is -4, so let's plug it in right away. -4x squared, 4, that's going to be -24 x to the 2nd. And -4 is -36. And I have b, so I need to distribute this, right? So I need to distribute this. So this is going to be bx to the 4 plus bx to the 3rd plus 3bx to the 2nd plus 3bx, and I need to do the c now this time. So this is cx cubed plus cx squared plus 3cx plus 3c, and then this is going to be dx squared plus dx plus ex plus e. Okay, now I need to set up this the constant with a constant, and like I did before. So -4 constant to the 4 power to the 4 power. I'm sorry, the x to the 4 to x to the 4 to x to the 4. Let's see what else. What else is x to the 4? There's only 2, right? So -4 equals -4. Okay, that's not. I don't need to worry about that. So b, I have only 2x to the 4th, and I'm lucky because let's see. Okay. Let's see what happens here. Okay. So that means that this is -4 plus b. So b equals 0, right? Because you can cancel these out. Okay, so we have b equals to 0. Let's see what happens after that. Okay, so b equals to 0. I don't need this anymore. So I have this b equals to 0. I'm gonna put that here. Okay, now I need to set up this one x3 with x3. So x3 here with x3, whatever I see, x3, x3, and that's it. There's only 2 x3s. So this is gonna be -2 equals b plus c, right? And I know that b equals to 0, right? From the previous part, right? From here, b equals to 0, right? So if b equals to 0, then this disappears. So c equals to -2. Okay, good news. That's nice. So I don't need this anymore. And I can find e from the equation that I put in the box, remember? So I can find e. So this is -a equals -6 plus e. So if I add 6 in both sides, I get e equals to -2. Okay, that's also good news. So I just need to find one letter and I'm done, right? So I have a. So I have a, b, c, and e. Okay, so let me erase this. So I have almost everything right now. So I have -2, -2, and these 2, right? So let me bring that here. So I just need to find a, b, c. I need to find d, and I'm done. Okay, let's see if something is with d. So d, the next one should be x squared. Let's do that in blue. So this is x squared. So x squared with this, x squared with that, x squared with this, x squared with that. So I can find it, right? Because I have, let me see, I'm looking for d, and that term has d. Let's see. So if I do that, I have negative 26 equals negative 24. I have 3b, I have c, and I have, let's see, I have d, and that's it. So this simplifies, so that's going to be at 24 in both sides. I mean, let me first replace everything, right? Negative 26 is negative 24. I know that b is 0, so this disappears. C is negative 2, and D is what I'm looking for. So this is going to be negative 26, cancel out with that. D is 0. D is 0, and I have E already, so that's the answer. So I have everything right now. So the answer is supposed to be A, negative 4, x plus 1, B is 0, C is negative 2, x squared plus 3, and D is 0, and E is negative 2, x squared plus 3 to the second power. And that's the answer. And as you can see, it matches with the one that I have above, right? It matches. So that's how you do this one. Okay? The next one. And this is the last one that we do. The improper fraction, you know that because we did that in class, right? So when the degree of the numerator is greater than the degree of the denominator, that's improper form, right? So we need to use the long division, right? So 2x squared minus 9x minus 10. And this is going to be x squared minus 5x. So you multiply by 2, it's going to be 2x squared minus 10x. Change the sign. This cancels out. You get x minus 10. You cannot do anything else. So this is part of your solution or part of your answer. Just keep it here for now. And now you need to factor the denominator, right? So that's going to be x minus 5. And then you have here 2x squared minus 9x minus 10. Multiply both sides by this expression, x minus 5. And you multiply the other side the same way, right? So this is a x plus b, x plus, we have a and x minus 5, right? So if you multiply both sides by this, you get this situation. So you get 2x squared minus 9x minus 10 equals, well, here they cancel, so this is ax minus 5 plus bx. So if we let x equals to 0, right? We let that happen, then this disappears, so you get negative 5a. This is 0, so that's negative 10. A equals to 2, so you solve already for one of the variables. We're almost done. And we need to do for the second case. So, my God, a x minus 5 plus bx. So if we let that, x equals to 5, let's put that in green, right? And if x equals to 5, this disappears. So we have 5b, 5, that's going to be 50, 5 is going to be 45, and minus 10, that's going to be negative 5, and 5b, b equals to negative 1. And that's basically it, right? So that's it. So you put this from the long division. So you put 2 plus what's b? A is your 2 over x, and your b is negative 1 over x minus 5. And that's it. That's your answer. Thank you, and I hope you do good on your test. Okay? Have a nice day.